Hello, we're on 5.02 geometry today, and we're continuing talking about our triangles. We're going to focus today on the Pythagorean theorem, which some of you may have done before. I know it's something they used to do a lot in middle school, and they don't seem to do it as much anymore. And also talk about some inequalities in triangles. Okay, so first, the Pythagorean theorem. So a really important theorem. We use it to find a missing side of a right triangle. It only works with right triangles, so very important to remember. And you would use it if you have 2 out of the 3 sides of a right triangle, and you're looking for the third. So let's say our triangle looks something like this, with our right angle there. And so this would be uppercase A, angle A would be across from lowercase a. Lowercase b is across from angle B, and lowercase c is across from angle C. So in this case, angle C is your right angle. The Pythagorean theorem states that side A squared plus side B squared, so the leg squared plus the other leg squared, would equal your hypotenuse squared. And remember, the hypotenuse is always across from the right angle. It should be the longest side in your right triangle, always. And something else that's important to remember is something called a Pythagorean triple. And what a Pythagorean triple is it's any whole numbers that satisfy the Pythagorean theorem. So, for example, the most classic one is a 3, 4, 5 triangle. So that means one side is 3, one side is 4, and the hypotenuse is 5. So if you put it into the Pythagorean theorem, would it be true? Well, we've got 9 plus 16. 5 squared is 25, so 25 equals 25. So since we end up with a true statement, that means it satisfies Pythagorean theorem, which means these 3 sides make a right triangle, and they're all whole numbers. So if you added anything with a radical in it or a decimal, then those would not be considered whole numbers, which means they would not be a Pythagorean triple. What's kind of cool about a Pythagorean triple is also you can take those 3 numbers now and multiply them all by the same thing, any number you want. So let's say 2. So if I multiply each of them by 2, I would get 6, 8, 10. And those numbers would also form a Pythagorean triple, meaning they would, if I did 6 squared plus 8 squared, that would give me 10 squared. So they would form a right triangle, and they are also whole numbers. So you can do that with any of the Pythagorean triples. 7, 24, 25 is another one, and we're going to see them come up as we go. All right, so the first one is a right triangle with one leg equal to 12, and the other leg is 16. Find the length of the missing side. Since we were given 2 legs, we know that it's going to be your hypotenuse. And then state whether the sides form a Pythagorean triple. So are they whole numbers, and do they satisfy Pythagorean theorem, which we are finding a right triangle. So we know they're going to satisfy Pythagorean theorem. We really need to just know, are they going to be whole numbers or not? All right, so let's first start by drawing a picture. I'm just going to make the picture look a little different so you don't always see the same. And one leg is 12, and 1 is 16. We want to find the missing side, so I'll call that x, or if you want to call it c, that's fine. Just remember in Pythagorean theorem, you must have it always is set equal to the hypotenuse squared, or the longest side squared. So the hypotenuse is across from the right angle, so that's our longest side. So we're going to take 12 squared plus 16 squared equals x squared, and I labeled that on my picture. And you can do those in your calculator if you need to. And then you get 400 equals x squared. Take the square root. Now, technically, whenever we take the square root, we have plus or minus. So it's plus or minus 20, the square root of 400. But we're talking about the length of a side, so we would reject that negative. So x would be 20, which means our three sides are 12, 16, and 20. So they do satisfy Pythagorean theorem, and this is a Pythagorean triple because they are all whole numbers. No decimals, no fractions, no radicals. All right, let's do another one. So a right triangle with a hypotenuse of 20 and a leg of length 8 units. Find the missing side and state whether or not it's a Pythagorean triple. So let's draw our picture. So maybe we'll make it look like this time. So here's our right angle. It says the hypotenuse has a length of 20. So again, that's across from the right angle. So I'm going to label that 20, and a leg that's 8. It does not matter which leg you put it as. It just has to be one of the legs. And let's call this side x. So now with our Pythagorean theorem, and why would we use Pythagorean theorem? Well, we have a right triangle, and we use Pythagorean theorem to find a missing side of a right triangle. It doesn't matter which one you call A and which one you call B, as long as your longest side goes in for your C value. All right, and then we're just going to simplify and solve. So 8 squared is 64, plus x squared equals 400. Subtract your 64, and we get x squared equals 336. Take the square root of that. Now let's put that into simplest radical form. You might check to make sure it's not a perfect square by typing in the square root of 336, and you'll find that it's not. One way to put it in simplest radical form to help you is to do 336 divided by x, and then go to your table and you're looking for any perfect squares that go in here. So I see 4 does, but then I see 84, which has a perfect square. So I'm going to go higher. And I see that 16 goes in, and 21 doesn't have any perfect squares from that. So I'm going to rewrite this. Always write the perfect square first. So 16, then 21. So 4 rad 21 would be x in simplest radical form. So that is our length. And then is this a Pythagorean triple? So look at your 3 side lengths. Are they all whole numbers? No, it is not a Pythagorean triple. 8 and 20 are, but 4 rad 21 is not a whole number. So that would not be a Pythagorean triple. Okay, let's do another one. To the nearest hundredth of a meter, find the length of each diagonal of a rectangle with length 5 meters and width of 2 meters. So let's first start, like we do with any problem that we can, is by drawing a picture. So draw your rectangle. And let's label this. Our length is 5 meters. Our width is 2 meters. Find to the nearest hundredth of a meter the length of each diagonal. So to draw a diagonal, you find the two opposite vertices and draw it in. So I'm just going to draw one diagonal in. And as we can see here, opposite sides of a rectangle are the same. We have two triangles that are congruent. You could say they're congruent by side, side, side. They share this side. They both have 5 meters as one side and 2 meters as the other. So if I can find this diagonal, I also know the length of my other diagonal. I'm not going to draw it on top of there so it doesn't confuse you, but I'll draw another picture to show you that one. So if I draw on my diagonal here, the other direction, from this vertex to this vertex, it's going to be exactly the same because, again, you have the same two triangles. And not only are they congruent triangles, but they are right triangles. So to find the length of our diagonal, focus on this one triangle at a time. So here we have this triangle right here. It's a right triangle. How do you find the missing side of a right triangle? Well, we use Pythagorean theorem. We have 2 out of the 3 sides. So are we missing the hypotenuse? And the answer is yes. So that's your C value. So we want to set it equal to C squared. So 5 squared plus 2 squared equals x squared. 5 squared is 25. 2 squared is 4. That gives us 29. Take the square root of both sides. Anytime I take the square root, don't forget your plus or minus. But we're going to reject the negative because it's the length of a segment. And this one said, though, not an exact value, but to the nearest hundredth. So you go to your calculator and just type in the square root of 29. Write out your entire decimal. 385. And then round to the nearest hundredth. So that's 2 decimal places. And it's a 5 after that, so it would round up to a 9. So 5.39 meters. And again, here, if you did Pythagorean theorem, you'd have 2 squared plus 5 squared equals x squared. And you'd get the same exact equation, get the same thing. So the length of each diagonal is going to be exactly the same. So in a rectangle, what did I do there? Diagonal, added an extra I. In a rectangle, the diagonals are always going to be the same. They're congruent to each other. Number 3, find the lengths of the sides of the triangle. And I'm going to give you a picture for this one. So it is a right triangle. This side is x, this side is x plus 4, and this side is x plus 2. So pause the video here and see if you can come up with an equation that you could solve based off of these side lengths and that it's a right triangle. All right, so hopefully you realize we need to use Pythagorean theorem. Again, we want to make sure we set it equal to our hypotenuse, the longest side squared. So I'm going to take x squared plus x plus 2 squared. And since that's a binomial, I need to square it and put it in parentheses. Equals x plus 4. Again, that's a whole quantity, so I'm going to square that. So hopefully you had something like this. Now that you have that, pause the video, see if you can try to solve this one on your own. All right, remember when you have a binomial squared, you need to write that out twice. Call that the double bubble. You got to write it out twice because you're squaring that entire thing. So I'm going to do that for both of these. Once I write it out twice, now I just need to FOIL it. So I'll bring down my x squared plus x times x is x squared plus 2x plus 2x plus 4. And over here, x times x is x squared plus 4x, middle terms, plus 4x, and my last terms. 4 times 4 is 16. Now I'm just going to combine some like terms on each side. So I've got x squared plus x squared is 2x squared. Remember, if you're adding, you just add the coefficients. It's always one operation down. If you're multiplying, then you would add the exponents. If you're raising a power to a power, you powerply. Over here, I can combine my two 4x's, so I get 8x. Now I see I have x squareds and x terms, so I want to combine them. And since I have an x squared and an x, I'm going to want to get it equal to 0. So I'm going to subtract everything from the right side and bring it over to the left so that everything stays, so that the x squared term stays positive. So 2x squared minus 1x squared will leave me with positive 1x squared. 4 minus 8 is negative 4x, and 4 minus 16 will give me negative 12, and then we're just left with 0 on that side. Now I have an x squared and an x. You want to get it equal to 0, and now you can factor. So you can factor using guess and check, or you could factor using p's and c's here. Guess and check's a little faster, and I choose that just because there's a 1 in front of my x squared. And if there's any other number than 1, that's when I would use p's and c's. So I want to multiply to negative 12. 1 times negative 12 is negative 12, and combine to negative 4. So again, you can use your calculator if you need to. So negative 6 plus 2 is negative 4. Negative 6 times 2 is negative 12. Set each factor now equal to 0. And I get x equals 6 and x equals negative 2. Now you just want to make sure both of those values will work. It's okay to have x values be negative. What's not okay is to have the length of a segment be negative. So I do have a segment that has length x. So if I put a 6 in there, we're fine. 6 plus 2 is positive. 6 plus 4 is positive. But if I put in a negative 2, I have a length of negative 2 and 0, which I don't want. So we're going to reject that and just keep your x equals 6. Now, the question said to find the lengths of the sides, so we're going to substitute that back in to get 6. 6 plus 4 is going to give me 10, and 6 plus 2 is going to give me 8. Is this a Pythagorean triple? Yes, this is actually the multiple of 3, 4, 5. If you multiplied them all by 2, 6, 8, 10. They are all whole numbers, and they form a right triangle. All right, next up, we're going to take the Pythagorean theorem and do the converse of that. So the converse of the Pythagorean theorem. So if a squared plus b squared equals c squared, then the triangle is a right triangle. So before I gave you that it was a right triangle, and you found a missing side. So if we know that a squared plus b squared equals c squared, then I know it is a right triangle. I also know I can use this to help me classify triangles if I'm given their sides and I want to classify them by their angles. And here's how. So if your longest side squared is greater than the sum of your legs squared, then the triangle is going to be obtuse. Think longest side squared is bigger, obtuse. But if you're thinking like this, you have to make sure you write the longest side squared first. It makes it much easier, less mistakes that way. If the longest side squared is less than the sum of the two legs squared, then think less, smaller, then the triangle is acute. And remember, so see, we're not talking about the hypotenuse anymore. C just represents the longest side of the triangle. And that's really, really important to remember. All right. So for each of the following, I'm going to give you 3 sides. And then again, I'm giving you side lengths. I'm not giving you anything to do with the angles, but I want you to classify each of those triangles as acute, obtuse, or right. So if c squared equals a squared plus b squared, it's a right triangle. If c squared is bigger than a squared plus b squared, it's obtuse, bigger, obtuse. If c squared is less than a squared plus b squared, then it's acute. So here are your 3 side lengths. All right, so first, what I would have you do is to decide which one is the longest side. And I'm going to circle that. So that's 14 squared, 14, just 14. So now I'm going to use my theorem. So I'm going to take 14 squared and I'm going to leave just an empty box. Again, I want you to write the 14, the biggest side first. So on the left side. And then on the right side, I'll take my other 2 sides, add them, and square them. So here I have now our 14 squared would give me 196. And then you can type this in your calculator. You can do it out. You could do 36 plus 121. And that's going to give us 157. So which one's bigger? 196 is bigger. So like, remember, it eats the bigger number. So it's eating your 196, which means the longest side, which we chose first, is bigger than the sum of the 2 legs. Therefore, it's an obtuse triangle. Let's try another one. So this one, I'm not going to make it as easy. They never stay super easy, right? So we've got 5 rad 6, 5, and 3 rad 2. All right, so first of all, looking at these, I might not know what the longest side is. So let's go to our calculator and type in 5 rad 6. And let's type in 3 rad 2. Whoops. There we go. Okay, so I've got like 12.2 about and 4.2. And I had 3 rad 2, yep. So, and then we have 5 is right here. So those are approximate values. So I'm just putting them in my calculator so I can kind of see which, I want to be able to tell which one's the biggest side. So now I know that 5 radical 6 is the largest side. So I'm going to circle that. And that's the one I'm going to write first. Now I want to square that. So if I leave it how I just wrote it now, that's not squaring all of 5 rad 6. That's just squaring the radical 6. So I really have to have parentheses around my 5 rad 6. It is so, so important to have parentheses. Don't forget those parentheses. Make a note to yourself. Okay, and then here it does not matter what order I put them in. But again, if I have 3 rad 2, I would lose a point if I wrote it like that because that's only squaring radical 2. I want to square that entire thing. Also, this one can be tricky to type in your calculator. So if you're doing it in one step, you would type in 5 radical 6 and then the squared button. I often just do it in 2 steps. So I would type in 5 rad 6, hit enter, and then hit the x squared button and then enter again. That's easier for me. But if you want to do it in 1 step, that's fine. I'll show you the difference here. If you just did this and didn't put the parentheses around it, you get a very different answer. So instead of 150, we get 30 because you would just square the rad 6, which would give you 6, and 6 times 5 is 30. As opposed to this one, you're squaring 5 squared to get 25 and squaring the rad 6 to get 6. And 25 times 6, it gives you your 150. Okay, so 5 radical 6 squared gives me 150. 25 squared, or 5 squared is 25. Plus, here you're squaring 3 squared to get 9, rad 2 squared to get 2, so we should get 18. That's in my head. Let me check it here. So I'm going to do it in my 2 steps. This is how I like to do it the best. So I type in 3 rad 2, Then I hit squared, and it gave me 18. All right. And now we're just going to decide, and you should be able to do this part on your own. So pause the video and see if you can get the same answer as I do. All right, so you should have gotten 150, 43, and 150 is bigger again. Therefore, we have another obtuse triangle. All right, the next one is 5, 5, 5, red, 2. So you probably can tell by looking at this which is going to be your longest side, but if not, you could always type in 5 rad 2 into your calculator, and we get a little over 7. So that's going to be our longest side. So pause the video here and try setting it up and solving this one. All right, again, double check your paper that you have parentheses around your 5 rad 2. So when you square that, you'd have 25 times 2, which is 50. And 25 plus 25, you should have also gotten 50. So this one, 50 equals 50. So therefore, it satisfies Pythagorean theorem, which means we have ourselves a right triangle. And one more. 4 rad 5, and 4 rad 6. Pause the video here and try this one completely on your own. Okay, so you should have squared, set these up. First of all, find the longest side, and then tried to figure out, is the longest side less than, greater than, or equal? And in this case, it should have been equal, so that should be an acute triangle. So on your papers, you guys should have all the work that leads to that answer. All right, so that is using our Pythagorean theorem to tell if something's a right triangle, acute, or obtuse. And then we also talked about using Pythagorean theorem to find the missing side of a right triangle as well. So the last thing we're going to talk about is our inequality theorem. So the triangle inequality theorem. So the triangle inequality theorem states that the sum of any two sides of a triangle is greater than the length of the third side. Okay. So usually in class, I will show this using like a piece of pasta or a pipe cleaner and show that if we make a triangle, then you have to have those two sides must be greater. Otherwise, if you took like a little piece like this, and actually let me make a big piece like this, and then a little piece like this, and maybe your other piece is like this. So is there any way you could possibly make a triangle out of this pink side, that black side, and this yellow side? And the answer is no. They will never, there's no way to get them to reach each other to form a triangle. And the reason that is because the sum of this pink and yellow side is not greater than this black side. So it should be that any two sides you take should be bigger than the third side. So if you take these sides, and if I took the black and the red side and then, made them straight in a straight line together, then they would be longer than this blue side. If I took the black and blue side and added those together, put them right next to each other vertically, then they would be longer than the red side. And if I took the red and the blue side and put those next to each other, they would be longer than the black side. So those would form a triangle. So any two sides must be greater than the third. Okay, so let's take a look at an example here. So find all the possible lengths of the third side of a triangle with sides 10 centimeters and 14 centimeters. Okay. So let's use this new rule to figure out the possible side lengths we could have. So it's not just going to be one answer, but there's a whole set of answers that we're going to get. So I know the two sides are 10 and 14. So the sum of any two sides must be greater than this third. So let's let x equal our third side. So 10 plus 14, those two sides, must be greater than our third side, which is x. Well, we also know that 10, the one side, plus x must be greater than our third side of 14. And then we also know that 14 plus x must be greater than 10. So I'm just taking my three sides, 14, 10, and x, and saying any of those two sides must be greater than a third when I add them together. So now I'm going to solve. So I've got 10 plus 14 is 24. We always want to write the variable first. I'm just going to flip this, and it's closed towards the x here, so it's going to stay closed that direction. Here I'm going to subtract 10 from both sides. So I get x is greater than 4. Here subtract 14. X is greater than negative 4. So when we think about this, we are talking about a triangle. So if we're talking about x as our third side, then x has to be greater than negative 4. Well, yes, it has to be greater than negative 4 because it has to be a positive number. But we also know that it has to be greater than 4. So all three of these must always be true. Now this one, it just doesn't really help me because we know it already has to be greater than 4. So anything that's greater than 4 is also going to be greater than negative 4. So I couldn't choose like negative 3, negative 2, or even 1 or 2 because those wouldn't satisfy this inequality. So all of our x values must satisfy all three of these. So now if I have a number that's less than 24 and greater than 4, that means it should work. So we want to, both of these inequalities must stay true. So x has to be greater than 4, and it has to be less than 24. So if you choose any side between those, now, doesn't mean including 4, it has to be bigger than 4. So 4.5, that would work, but 4 would not work. 4 would actually, that would be like if you had two pieces. So if the sum of the two sides, the blue and the red, is equal to the third side, so if you added those two together to get black, try to think, could you make a triangle out of those? Well, if they're exactly the same length as x, they would just end up falling right next to each other, and you'd have one line on top of the other. You wouldn't be able to make the angle from it. And again, you can do that using pipe cleaners too to see that. Now we also have a quick trick here. It only works if you have, or if you're given actual values, so not variables, but whole numbers or any rational number. But we can say that here x is greater than 4. We got that by taking the difference of our two sides that were given to us. And the 24 we got by adding, so taking the sum. So this will work anytime you're given the two side lengths, then you don't have to go through all this work. You can just say, okay, well, I know then the third side has to be bigger than the difference, and it has to be less than the sum of those two sides. I started at 1 again, but what were we at here? 5. Let me change that to a number 6. So we'll continue our numbering. So this will be 7. So for each of the following, I want you to tell me can the three lengths be sides of a triangle? So they can only be sides of a triangle if the sum of any two sides is greater than the third. Say that out loud to yourself. The sum of any two sides is greater than the third. First option, 8, 15, and 12. So think about, if you added any of these two sides, would it be bigger than the third? So 8 plus 15, is that bigger than 12? Yes. 15 plus 12, is that bigger than 8? Yes. 8 plus 12, is that bigger than 15? Yes. So all of them satisfy it. I can write that out for the first one. So 8 plus 12 is greater than 15. 15 plus 12 is greater than 8. And 8 plus 15 is bigger than 12. Therefore, yes, that is a triangle. Quick trick, you could really just take a look at your two smallest sides, and if those work, then you know that the others are going to work too, since this number is bigger in the middle. So once we see that 8 plus 12 is bigger than 15, you know that's going to form a triangle. Try another one. So this one, do 5, 5, and 9 are your three sides. Pause the video, tell me whether or not this could form a triangle. And hopefully you looked here and said, okay, well, 5 plus 5 is 10, which is bigger than 9. So those are my smallest two sides. So yes, this could form a triangle. 9 plus 5 is bigger than 5. We know as well. And 5, 7, and 2. Pause the video. Tell me whether or not those three sides can form a triangle. And here you would take, again, your smaller two sides, 5 and 2. And 5 plus 2, is that greater than 7? And this is a little tricky. It is not bigger than 7. 5 plus 2 equals 7. And when we do the theorem, it says the sum of any two sides must be greater than the third. So this is no, it's equal to the third side. So that would be that one where you can't make a triangle because the sum of the two sides equals it. There's nowhere to make your triangle. All right, let's try, what was that, 7 I said? All right, for number 8, I want you to find all possible values for x. Given these three sides. So 3x is one side, 2x plus 7 is the second side, and 5x minus 3 is the third side. Now we can't use our quick trick like in number 1 because we don't just have the two of the three sides given to us. This time they're given to us in terms of variables. So we have to set up our three different inequalities like we did in number 1. So we're going to take 3x plus 2x plus 7. That sum of those two sides has to be greater than the third. Then I'm going to take 3x plus 5x minus 3. Those sum of those two sides must be greater than the third side. And then the last two sides, 2x plus 7 plus 5x minus 3 has to be greater than our third side, which is 3x. So now let's combine what we have here. So combine my like terms over here. I have 5x plus 7 is greater than 5x minus 3. I'm going to subtract 5x from both sides. And that's just going to cancel out. So I just end up with 7 is greater than negative 3. That's true. Or you could have also ended up with 10 is greater than 0. But that doesn't help me at all. The variables dropped out. So that's just a null case. All right, over here, I'm going to combine my like terms. I get 8x minus 3 is greater than 2x plus 7. Subtract my 2x. So I have 6x minus 3 is greater than 7. And then add 3. So I get 6x is greater than 10. Divide both sides by 6. And x is greater than 5 over 3. Okay, and then the last one, pause the video here and combine your like terms and solve for x as an inequality. All right, so you should have gotten 7x plus 4. Subtract your 3x over. You should already have done this, so I'm going to go quickly. And we get x is greater than -1. So again, all three of these have to be true. Now this one we said doesn't really help us at all. Okay, so we know we have to be greater than -1 and greater than 5/3. Both have to be true. So if I chose 0, 0 is greater than -1, but it's not greater than 5/3. If I chose negative, or if I chose a number like 3, let's say. 3 is bigger than 5/3, and 3 is also bigger than -1. So any number that I choose that's bigger than 5/3 is also always going to be greater than -1. So we already have to be greater than 5/3, which is like, 1.6 repeating. So if we have to be bigger than that, then this one, again, is not going to help us here. So our final answer would be x is greater than 5/3. So any number you choose that's bigger than 5/3 will make all of those inequalities happy. Okay, let me add another page here. And give you another question. For an isosceles triangle. So are we on 9, I think? Yeah. Okay, so two sides of an isosceles triangle. So what is an isosceles triangle? Hopefully you're saying a triangle with two equal sides or two congruent sides. And that has sides 3 and 7. Which of the following, so multiple choice here, could be the third side? So A is 9, B is 3, option C is 10, and D is 7. Okay, pause the video here, take a moment and answer this question. All right, so if we know that it's isosceles, we know two sides are the same. We already know that one is 3 and one is 7. So there's a couple different ways you could do this. You could first find out which of these choices would make it isosceles. So then you could probably narrow it down to either 3 or 7. And then we need to figure out which of those would be possible. So whenever we have a triangle, the sum of any two sides must be greater than the third. So let's use our sum difference rule, since this time we're given two actual values. So I'm going to take the difference of those two and the sum. And I know that any number side length between those two values will work. So 7 minus 3 is 4. And 7 plus 3 is 10. So any number between 4 and 10 will work. So that shows us also that 10 wouldn't work because that's equal to 10, but we already crossed that off anyway. So is 3 between 4 and 10? And 3 is not between 4 and 10 because it's smaller than 4. So is 7 between 4 and 10? Yes, it is. So that would be your final answer. So really important to be using this sum difference rule. It will make things a little bit faster. But if you don't have nice numbers to work with, like if you have variables as your side lengths like you did on number 8, then you have to set up the 3 different inequalities and solve them for what would be true for all 3 of them. All right, that is it for today. Hope you guys are all doing well, and I hope to see you soon. Have a great day. Pie out.